Okay, let's go ahead to page 23.
Yeah.
And remember, we're starting with our example of Abba, our father. That how many ways can we rearrange the letters of Abba? Well, in the numerator, how many ways are there? 4 factorial. And then we have to divide by 2 factorial for the ways that we could arrange A. And then divide by the number of ways you could arrange B, and we get 4 factorial. So how many ways can you arrange the letters of 3 A's and 4 B's? What would the numerator be? 7 factorial. And the denominator would be? Yeah. So if we had written that out, well, it would take us a while. It would have taken us a while. Let's see which board I'll be writing on. I guess I'll be writing on that one.
Dr. Case, do you mind scooting the book over a little bit so we can see the whole thing?
That would work.
Thank you.
I mean, we would have to sit here and write A. No. B, B, A, B. You know, you get the idea. Lots of things. But you can also think of it as just flipping a coin, right? Heads, tails. Or boy, girl. So for example, if you ask your friends if they have 3 children in their family, what's the likelihood they're all girls, and what's the likelihood there's 1 boy and 2 girls in their family? Actually, if you do this study, for some people it's counterintuitive, but with mathematics it's not. Go ahead and figure out what's the probability for arranging the letters in Mississippi. M-I-S-S-I-S-S-I-P-P-I. You have to do a little counting there. And so I hope you figured out 11 factorial, 4 factorial, 4 factorial, 2 factorial, and 1 factorial. Notice that these numbers, 4 plus 4 plus 2 plus 1, have to equal 11. By the way, to show you how you might calculate that, it might be helpful to know that if you go to Math button here, the Math button there, and you go over to probability, there's the exclamation point. We'll be using this NCR and NPR as well. So you should be able to find that on your calculator. Oh, how many ways can you get flip 5 coins and get 3 heads? Well, you can think of this as having 3 H's and 2 T's. So how many ways can you rearrange letters of 5 letters with 3 H's and 2 T's? What will the numerator be? 5 factorial over 3 factorial over 2 factorial. And we'll see this a little bit later in combinations. And for the formula for repeated letters would be n factorial, r1 factorial, r2 factorial, r out to rk factorial would be our situation. And by the way, this does have a symbol. This we will call this as 5 choose 3, or on your calculator it would be 5 choose 3. I don't like this. I like this. This is the notation that we'll use. But we don't get the combinations until 2 more pages. All right, let's take a look at tool number 1. And that's the multiplication principle. And one way you could do this is think of a tree diagram. like I could possibly have 3 ways to do the first thing, and then 2 ways to do the next step, and then maybe 4 ways. Maybe 4 ways is not a good idea because I can't quite fit them all in. So how many branches do I end up with? There are 3 ways to do the first thing, 2 ways to do the second thing, and 4 ways to do the last thing altogether. How many branches do I get counted? 24. So the key here is that there are equally number of ways to write each step. It would not count if you went to sort of like a baseball series or an NBA series where you go until a person wins 4 games. Because it may take 4 games, it may take 5 games, it may take 6 games, it may take 7 games. So these are sort of trim trees. Like, let's say you're playing tennis, and let's just make it easy, the U.S. Women's Open, and let's suppose Serena wins, or her name's not Asaki. Who's the? Asaga?
Yeah.
All right. And then Serena wins, and then it's done. And Asaga wins. Okay, so this is a situation where it's a trim tree, and so this principle won't work. And that principle is, in a multi-stage choice, if the first choice can be made in n1 ways, and for each of those choices, the next one can be done n2 ways, and the kth choice could be nk ways, then we multiply n1 times n2 out to nk. But they have to be the same after each stage. It can't be that you trim the tree after a stage. All right, so let's go to kind of a minimized Chick-fil-A. We have a value meal of 3 sandwiches, 2 sides, and 4 drinks. Although those are our choices, we can only get 1 sandwich, 1 side, and 1 drink. So this would be 3 times 2 times 4, or 24 different ways. So in this case, I could get the spicy chicken, the original chicken, and the bacon deluxe chicken. What's that one called? Oh, it does cost money?
Yeah, they changed that.
Oh, okay. I guess I'm under old systems. And you could get the side, the very unhealthy fries, or the very nice banana. And then, no more banana? Just fries. All right, just fries. All right, for those of you who are in Ohio, a standard license plate in Ohio, not the fancy or the glamour or the whatever they call the individual. Vanity, that's right, vanity, 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 all is vanity, right? Ecclesiastes. Okay, so you get 3 letters followed by 4 numbers. How many standard license plates are there in Ohio? Well, how many letters are there?
26.
26. I guess still in Ohio, there's 26. And then the 4 numbers. How many numbers are there? 10. All right, so 10 times 10 times 10 times 10, and you get 175,016, or 175,016,000. Of course, then you have to kind of go through and clean up all the double entendre ones and the curse words and anything with Michigan in it. So then, all right, let's go on to the next page, page 24. So we already talked about this factorial notation, that n factorial is n times n minus 1 times n minus 2 all the way down to 2 times 1. And we also talked about that 0 factorial is the number 1, and that's sometimes, people don't like that sometimes. Anybody feel uneasy about 0 factorial equals 1? You do? All right. But it's 1. How many ways is there no way how many ways can you not make a choice? One way. So that's kind of one idea. Gamma function, whatever. Mitch?
Where's that, right about the 1 after factorial, on the very far right? 2 minus 1. 2 minus 1?
Yeah. No, 2 times 1, not minus, times. All right, let's try to sample 2 jurors from 6 males, and let's calculate oh, sorry, I skipped one. Toss a fair coin twice. What's the probability of exactly 1 head? Well, I could have heads tails or tails heads. So this is an example where I'd have 1/2 times 1/2 plus 1/2 times 1/2, or 1/2. So in other words, 1/4 plus 1/4 gives me 1/2. Let's try the next one where we're going to have 2 jurors, 6 males and 3 females. What's the probability that we get all female? Well, in this case, what's the first one have to be? A female. What's that probability? Yeah, 3 out of 9. And we've used up a female and a possible juror. So what's the next one going to be? What's the probability of the second one being a female? 2/9. 2/8. And so we get 6/72, or 1/12. Now, what about the probability of 1 each? Well, the first one could be female and then a male, or vice versa. So we could get 3/9 times 6/8 plus 6/9 times 3/8, and I believe that gives you 36 out of 72, or 1/2. Yes. Now, what if we had all 3? Why don't you go ahead and figure out part A and part B, and we'll go through part C together, depending on how far you get.